Hi, Victor Morganti here from Fact Engine. We're going to be looking at Metadata Lineage in the Boston Conceptual Modeling tool, which will be coming to you in the October 23 release of Boston. And if you're watching this video after October 23, then it's already in Boston. We've got the Boston Conceptual Modeling tool open in front of us, and in the Model Explorer on the left hand side we've got a model called ECSS EST7041, which is a large model that's been kindly shared to us by ESA, the European Space Agency, and it is a model for telemetry data for satellites. If we look at the number of pages in the model, it's quite a large model, and we can open a page. We'll open an object role model page, and on that page is a subsection of the conceptual model for the entire conceptual model, and it's in object role modeling. So we're going to focus on one particular object type, subservice type, within this model, and where you can imagine that satellites have something akin to a service bus where telemetry data is collated and channeled down to ground stations on Earth. Now, and where the service bus has services of service types and subservice types. Now, if we look at the subservice type in its entity relationship diagram view, we can see where it forms a larger part of the conceptual schema, and we know in Boston that we can go also from any of the views to the corresponding view in, say, a property graph schema view, and back to our object role model. If we look at the subservice type object type within the model dictionary, we can see it here within the object role model view in the model dictionary as an entity type, and we can look at it within the entity relations, so as an entity type within the entity relationship diagram view, and here it is, and here's the columns on the table that would be formed for this particular object type if this conceptual model was converted into a database. It has a primary key of subservice type name. If I go back to the object role model and click again on the object type, so the entity type, in the verbalization view we can see that the reference scheme is subservice type has service type name, and there's other various information about the related concepts to subservice type within the verbalization view. For instance, subtypes that it has within the conceptual model and fact types that it relates to. If we look at one particular fact type here, subservice defines mandatory subservice type. We can see its corresponding fact type in the object role model. Service type defines mandatory subservice type. Now we know that using object role modeling we get a semantic view over our conceptual model and any related database or data lake or semantic layer, and where the verbalizations or the natural language business language defined by the predicates in object role modeling gives us the semantic view, or a more semantic view over our conceptual model, rather than just column names in a entity relationship diagram view. If we look at one of these unary fact types where we're saying subservice type realization is required by tailoring, we can see where that's a Boolean column on our corresponding entity within an entity relationship diagram view. So is required by tailoring, and where it's a Boolean value as an attribute in the verbalization when I click and select on that. It's a very big model, and if I clear the search box on the model dictionary and count the number of entities or effective tables in a database if it was converted to a database or a data warehouse, there's over 200, or well, there's 294 tables in this particular database if it was converted to a database. In the object role model view, there's over 2,600 components within the model. So that's just the object types. We then of course have the fact types and a whole series of constraints. So over 2,000 components in this model. It's quite a large and extensive model. If I wanted to know where the documentation was for where this particular object type came from within a corpus of documents that define the model, we do that in Boston by storing what's known as metadata lineage. So we're looking at the metadata rather than the data in a database, and where we store information about where the metadata came from to create this conceptual model in the first place. If I click on the entity type and go to the glossary view inside Boston, we can see a glossary of all the object types and fact types within the model, and here's subservice type, and here's all the related fact types and constraints and subtypes for that particular object type. It's all in natural language. For instance, we can find again our fact type subservice type is mandatory for service type, and where I can make that a little bit easier to view by just hiding those greyed out fact type names. And you can imagine where you could use this semantic information for documentation. So let's have a quick look at how we would do that. Let's go to copy to clipboard. So we're going to copy all that semantic business rule information, and we're going to go to Microsoft Word and just dump that in there as plain text. And you can see that there's constraints in here, so I'm just highlighting a constraint. If some subservice type is type of some subservice that belongs to some service, then that subservice type is defined within some service type that is type of that service. So that's quite a complex business rule that's been captured in the object role model. If I go to the top, we can see where subservice type has service type name is the reference scheme defining the effective primary key on subservice type, and the other related fact types as well in natural language. So we can generate documentation, and you can imagine where you might have this particular piece of documentation which you can extrapolate and put extra verbiage around. It might be in section 5.3.2 of our document. This particular model and this particular page within the model is called 5.3.2, and that becomes very pertinent to what we're looking at in terms of data lineage for this model. So these are the various sections of a document from which this particular conceptual model could either be constructed, but we can look at it the other way around too, where this is where this particular model came from. You can look at it either way. We know that for this particular model, ESA used the object role model to create the document, but let's say we were going the other way. I've actually got the final document here in PDF form, and it's a document for the telemetry and telecommand packet utilization standard defined by the European Corporation for Space Standardization, and it has its various sections, and it's 656 pages long, so it's quite a large document. If I go back to the model and the glossary view, and I'll just reselect subservice type, I can click on subservice type, right click, and go to the lineage context menu. Let's open lineage, and we can see the metadata lineage for that particular item. So it comes from this version of the document, so ECSS EST 4071C. If I go back to my document, there's the document number there, and it's in section 5 on page 27, and you can store paragraph or sentence information in the metadata lineage in Boston. If I had the corpus on my C drive, you can point to where the actual document lives on your C drive or your shared network drive. If you convert the document to JSON to load this metadata lineage information into Boston in the first place, you can store the location of that JSON file, so that's in a JSON folder. And we're looking at section 5.3.2. So what we're saying is that the definition of subservice type can be found within section 5.3.2 within this document, and where to find that document. We're looking at page 27, so let's go back to the document and open page 27. And now we're looking at subservice type and the business rules related to what is a subservice type within the overall conceptual schema. If we look at the first sentence, each service type shall define at least one subservice type, and go back to our model and look at that particular section within the conceptual schema. We can see where a subservice type defines a subservice type. Going back to the documentation, we might see that each subservice type shall be uniquely identified by exactly one subservice type name. And of course, if we click on subservice type and look at its reference scheme, subservice type has subservice type name. And of course, when we generated our document, we saw that the reference scheme, so the unique identifier for subservice type, is subservice type name. So let's recap there. In Boston, for a conceptual model, you can store the model as a object role model or an entity relationship diagram, or a property graph schema. From within the model, we can go to the model dictionary and find that type, say, within the property graph schema view, or its corresponding entity relationship view, and see the effective columns on the tables, or the object role model view. And then when we go to the model dictionary, we can see the semantic natural business language business rules, and they are business rules because, for instance, we're saying such things as subservice type is one standard subservice type, so we're adding cardinality rules there within our object role model. When we go to the glossary itself and go to lineage, we can see the metadata lineage for that particular model element, the document where the definition of that part of the conceptual model came from, the section number, the page number. We can store extra information. These fields are configurable, so if you need extra information in your data lineage, you can configure that. And we know that in section 5.3.2 on page 27 within this particular document, I'll find the definition of subservice type. So thanks for watching. That's Metadata Lineage in Boston, and that'll be ready for you in October 2023.
Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas, and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.